Hi everyone, this is your math guru. In this video, we're going to learn about the compound angles. We're going to use it to simplify our work, to expand. We're going to use it for reduction, and also sometimes we may have to use special angles. Please don't forget to click on the like and the subscribe button below for more easy to understand math concepts. For example, if we're given sine x minus 20 and we're trying to figure out which of these identities for compound angles we're going to use. To start with, it's a sine, so it's either this or this. If you look at the angle in the bracket, it says x minus 20, so the sign we're looking for is the minus sign. This as the plus sign, and then this as the minus sign, such that we have sine alpha minus beta is similar to x minus 20. So if I compare it with this expansion, this will be my alpha and this will be my beta. So using exactly this expansion, what I'm going to have is I have sine alpha. In this case, that will be sine x is alpha, remember, multiplying cos beta, that will be cos 20 degrees. Then I have my minus cos alpha, cos x in this case, multiplying sine beta, that's sine 20 degrees. Let's look at another example. If I'm given cos 10 plus x, I have 10 plus x, and I go back to all my formulas to try and figure out which one of it is similar to 10 plus x. Obviously that's cos, so the only ones I'm going to use are the ones I'm highlighting. But if you check the angle of the bracket, the compound angle says 10 plus x. So I'm not going to use this because this says alpha minus beta. I'm going to use the one that says alpha plus beta. So I'm going to put my alpha here and my beta here. So using that expansion, I have cos alpha cos beta. In this case, that will be cos, because my alpha is now 10 degrees, so that's cos 10. Cos beta, beta is x, minus sine alpha, sine beta, so that will be sine 10 multiplying sine x. Let's look at another example. In the next example, we have to prove that sine 75 degrees equals root 2 in bracket, root 3 plus 1 close bracket, all divided by 4. I start with my sine 75. I have sine 75 because I need to break it down to look like one of the compound angle identities. So therefore, using my special angles, I'm going to break sine 75. That will be 75 into 45 degrees plus 30 degrees. I could have used 30 degrees plus 45 degrees. I'm going to get the same answer. And looking at what I have, I'm going to go back to my identities for special angles and figure out which of the expansion I'm going to use. Because as a sine, I'm going to use either this or this, but I have 45 plus 30, and the one that has the plus is the first one. So therefore, I'm going to use this expansion such that this will be my alpha and this will be my beta. So therefore, this will be equal to sine alpha cos beta, that's sine 45 cos 30 plus cos alpha sine beta, cos alpha, that's cos 45, sine beta, that's sine 30 degrees. And you can see that 45 and 30 degrees are part of the special angle identities. So I'm going to have sine 45. I start simplifying. So that's 1 over root 2. That's sine 45 times cos 30. That root 3 over 2 close bracket plus, for the second term, cos 45. That's 1 over root 2 multiplying sine 30, 1 over 2. That's the same as root 3 over 2 root 2 plus, I'm going to take out the bracket, and then for the second term, if I simplify, I have that as 1 over 2 root 2. Now I'm adding this fraction, and they both have the same denominator, so I'm going to put them under the same denominator. That's 2 root 2, and at the top I have root 3 plus 1. Now I'm going to rationalize. That's multiply both my numerator and my denominator by root 2. So what I have is, therefore my sine 75 degrees will be root 2 multiplying root 3 plus 1, and for my denominator I have 2 root 2 times root 2, that's 2 times 2, and that will give me 4. I've been able to prove as shown. Let's look at more examples. If we're asked to simplify cos 15 degrees without the use of a calculator, I know that I can break down 15 degrees using my special angles. I could either use cos 45 degrees minus 30 degrees, or I have that's also equal to cos 60 degrees minus 45 degrees. 45 minus 35 will give me 15. 60 minus 45 will give me 15. For this example, I'm going to use cos 60 degrees minus 45 degrees. So therefore, I have cos 15 degrees equals cos 60 minus 45. And if I go back to check the expansion, 60 minus 45, I'm going to use this formula, which says cos alpha minus beta. In this case, this will be my alpha, and 45 will be my beta. So therefore, I have that as cos alpha, which is cos 60, multiplying cos beta, cos 45, plus sine alpha, sine 60, multiplying sine 45 degrees. So therefore I have that as cos 60, that's 1 over 2, times cos 45, 1 over root 2, I'm going to put that in a bracket, plus sine 60, that's root 3 over 2, remember I'm using my special angles, then sine 45, 1 over root 2. If I simplify, I have 1 over 2 root 2 plus root 3 over 2 root 2, and because they have the same denominator, that's 2 root 2, I have 1 plus root 3. I'm going to rationalize by multiplying both the numerator and the denominator by root 2. So therefore I have root 2 and bracket 1 plus root 3 divided by 2 root 2 times root 2, that will give us 4. And if I simplify further using the root 2 to expand my bracket, I have that as root 2 plus root 6 over 4. Now note that all the examples I've given so far, I'm going from the compound angle into the expansion. Now I'm going to give you a couple of examples whereby I have the expansion given, I need to reduce back to what the compound angle question is. So in the first example, if we're given cos 40 degrees cos x plus sine 40 sine x, we need to go back and check which of this expansion has a similarity to what I have. I'm going to start by tagging my angles. Because I have 40, I'm going to tag my 40 as the alpha and my x as the beta. So basically what I'm looking for is the expansion, that is cos alpha cos beta plus sine alpha plus multiplying sine beta. If I go back to the question, the expansion that has cos sine, I have the first one definitely not the first one. The second one, cos alpha plus beta, I have that as cos, sine. That looks like it because it's similar to cos alpha, cos beta minus. No, I'm going to use that because I have here a plus, but here I have a minus. So therefore, I'm going to go to the next one. The next one says sine cos, sine. I'm looking for a cos, sine, so definitely not this. And then the last one I have cos alpha, cos beta, plus sine alpha, sine beta. This looks like what I'm looking for. And if I reverse, what I'm going to have is cos alpha minus beta. Alpha in this case is my 40 degrees minus beta is my x. So the compound angle is cos 40 degrees minus x. In my last example, I have cos 25, cos 35, cos 25, sine 35. So sine 25, I'm going to tag my 25 degrees as my alpha, as shown, and my 35 degrees as my beta. Now, going back to all my expansions, I need the one that has sine alpha cos beta plus cos alpha sine beta. That is looking like the first one. So therefore, I'm going to break that down to be sine alpha plus beta. Alpha in this case is 25 degrees and beta is my 35 degrees. And that will be sine 25 plus 35, that's 60 degrees. And using my special angle, that will be equal to root 3 over 2. Thanks for watching. Bye.